In this lesson, we're going to look at Lewis structures of ionic compounds. Let's begin by talking about ionic compounds. What's an ionic compound? Well, in an ionic compound, electrons are transferred from the positive cation to the negative anion. So remember, groups 1 to 3 on the periodic table, actually 1 to 4, I should say, those are the groups that give up their electrons and they have a positive charge. Anions are groups 4 to 7. They have between 4 and 7 valence electrons, and they need to gain those extra electrons to be happy. So we have the cation who needs to lose the electrons, and we have the anion that needs to gain the electrons. And when you put those together, it is a wonderful match. That is an ionic compound. So ionic compounds are neutral. That's a key right there. So we want to make sure that if we have a -2 anion, we have a +2 cation to cancel those out. So let's look at an example. Again, the purpose of this lesson is to go through Lewis structures of ionic compounds. So here's an example. We have sodium, Na, and chlorine, Cl. In our Lewis structure here, on the left, you can see that we have an arrow representing the transfer of the one valence electron that sodium has to chlorine. Chlorine has 7 valence electrons, and it needs to gain 1 additional valence electron to have that perfect 8. So we use arrows to represent how the electrons are being transferred. The arrow should always point from the cation to the anion, because remember, the cation is giving up its valence electron to get a positive charge. The anion is gaining that electron to get a negative charge, and those two charges should cancel each other out. So when we have our finished product here, we're going to write both of them. So before we were just writing one of the ions. When we write our compound out, we need to have both of them. So sodium here has no valence electrons written around the ion here, and we have our positive charge. Chlorine has 8 valence electrons, and it has a negative charge. The formula is going to be NaCl. The cation, remember the positive cation, always comes first when we write out our formula. We're going to go through a couple of examples, and hopefully by the end of this lesson, you'll be a pro at doing these Lewis structures. All right, in this next example, it says model the formation of the ionic compound between fluorine, F, and magnesium, Mg. So let's begin by taking a look here at what we've got. Fluorine has 7 valence electrons. Magnesium has 2 valence electrons. Magnesium is going to be our cation. It's losing those valence electrons. Fluorine is going to be our anion. It's gaining those electrons. So let's draw out magnesium. Magnesium has 2 valence electrons. Fluorine has 7 valence electrons. Actually, let me change one of these dots. Okay, so fluorine has 7 valence electrons. Magnesium has 2. Okay, magnesium needs to lose all of those valence electrons. So let's draw our arrow going from magnesium to fluorine, representing that one of those electrons is going. So fluorine now has a total of 8 valence electrons. Magnesium still has 1 valence electron that it needs to get rid of. So to make this work, we're going to add a second fluorine. And again, each fluorine has 7 valence electrons. And again, I'm going to draw another arrow here. So this other valence electron is going to go to the second fluorine so that it's losing all of its electrons and fluorine is gaining. Okay, so now let's kind of write out what we have here. So we have one fluorine that has 8. Okay, so fluorine has 8. So it gained 1 electron, so it's going to have a negative charge. We had magnesium. Magnesium, since it gave up all of its valence electrons, we write it like this. It gave up 2 valence electrons, so it'll have a +2 charge. And then we have one more fluorine, which is gaining, so it'll have a total of 8. Okay, so since it picked up an electron, it will have a negative charge. Now, when we write the formula, the rule is cation first. So magnesium is going to go first, okay, and then the anion, fluorine. Now, if you notice, we had two fluorines, one and then two. So when we write out our formula, it's going to be Mg and then F2 because we had two fluorines, and that will be our formula. Let's do another one. In this example, we have lithium and oxygen. So if we look on the periodic table, lithium has one valence electron. It's going to be our cation. And then we have oxygen. Oxygen has 6 valence electrons. It's going to be our anion. So again, let's start by drawing our initial structures. So I have oxygen that has 6. Okay, and then I have lithium. Lithium has 1. All right, so lithium being a cation is going to lose that electron. So it's going to transfer over to the oxygen. So lithium will now have 0, and oxygen will have 7. Oxygen's not happy, though, because it doesn't have 8 yet, so we need another lithium with another valence electron, and we're going to go ahead and transfer that over. So now each of the lithiums have lost their valence electrons, and oxygen has gained the 2 electrons that it needs to have 8, so everybody's happy. So let's go ahead and write out what this looks like. We have lithium. Lithium lost an electron. Then we have in the middle, we have our oxygen. Oxygen has a total of 8 valence electrons. Okay. It gained 2 electrons, so it'll have a -2 charge. And then we have lithium. Lithium lost an electron, so it will have a +1 charge. When we write out our formula, it's going to be lithium. And because we have 2 lithiums, one here and one here, we will have a subscript 2 representing that we needed 2 lithiums. And then finally, we'll have our oxygen. This is our formula right here, Li2O. Let's do one last example. All right, it says model the formation of the ionic compound between calcium, Ca, and sulfur, S. Calcium has 2 valence electrons. It's going to be our cation. Sulfur has 6 valence electrons. It's going to be our anion. All right, so let's take a look here. So we've got calcium. We have sulfur. Calcium has 2 valence electrons. Sulfur has 6. All right, so calcium is going to need to lose both valence electrons. Sulfur is going to need to gain 2 valence electrons. So one of these calciums is going to be transferred here, and then the other is going to be transferred here. So both of the valence electrons are going over to a single sulfur, and it's going to create a bond. So when we write this out, we have Ca, Ca. Calcium lost 2, so it will have a +2 charge. And then sulfur will now have a total of 8. And it will have a total of a -2 charge. We only had 1 calcium and 1 sulfur. Calcium is our cation, it will go first. Sulfur was our anion, it will go second. So our formula will be CaS. And that, in a nutshell, is how to do our Lewis structures of ionic compounds.